this is not even the worst I've been doing. Well, first of all, it's a pleasure to be here, but also not, because if I'm here speaking, it's probably because we didn't have enough submissions, so they had to call me to do a talk. We had to resort to internal people. But yeah, in the recent years, since the last 7 years, I've been the CTO and co-founder of Probably. Probably is essentially a vast and discovery tool. We basically find your assets, find your vulnerabilities on the web, API, and then we hope you fix them. I'm not going to talk about it, otherwise it would be a vendor presentation, but feel free to reach out. I've been in the security world for almost 20 years. The good thing, I think, is that I started as a developer, actually in a security team as a developer, a full stack developer. We didn't call it that at that time. But it was good because I came from the other side. So I know the pains of running a PHP site and then someone asking me to update it to PHP 5 3 years later. And no, I cannot do it. So actually that brought me some nice experience. And all of them, or all of that, or most of that, was in Portugal Telecom. Me and Nuno, but is here. We co-created the web application security team, the application security team of SAP. SAP was like a portal, much like Yahoo and Google in the golden days, with millions of users, and they were fun times. And then recently, last year or 2 years ago, I joined these guys to bring the OWASP chapter back. So the talk is going to be about the challenges of security testing in CI/CD pipelines, and hopefully I'll try to give you some guidance, some tips. Most of those tips come from either my own experience, the experience of the teams around me, but also some experience collected from our customers at Probably. But there's like no golden solution or silver bullet for the challenge that I'm going to do. So the motivation to put security in the CI/CD pipelines. There's a few motivations, and one is that everyone is talking about it, and they have been talking about it for the last 10 or 15 years. It's all buzzwords: shift left, shift right, pipelines, automation, DevOps. And some of those might sound like and buzzword bingo, like vendor bingo, but that's actually good. I came to realize that all of them point towards the direction, which is more testing and eventually automated testing. So actually, this is a good thing because it's creating awareness. It's promoting the testing in all its methods that we can do testing. It's promoting the testing of applications earlier and faster. So this is actually a good thing. This buzzword bingo. And well, testing more and testing earlier has a lot of advantages. Who here works in cybersecurity? With some kind of connection to cybersecurity? Maybe the others are probably developers, students, and so forth. So most of you know the reasons, the advantages, and apparently there are no downsides. We get more secure software. The earlier the detection, the cheaper it is, according to NIST. And it's normally easier to fix something early, like while we are coding, and we don't have to deploy it again. If we test applications earlier, it also makes the development process faster because you don't hit a roadblock further ahead when basically on a Friday at 6 p.m. you call the security team, hey guys, can you test my application? I need to put it in production before the end of the week, otherwise I get fired. So you know the drill. So if you test earlier, maybe that security team can say, okay, fine, put it in production because I know that there were a barrage of tests before. And because it's automated, it's normally predictable and repeatable, and it also empowers the developers because the developers ultimately, they are the ones that code the vulnerabilities, or most of the vulnerabilities. Well, not on purpose, but they are the ones that enter the vulnerabilities in the code, and they are the ones that fix them. So, like any other bugs, why do I need to go back and forth with the security team for them to tell me what I need to fix? If I can identify the vulnerabilities or the bugs by myself, the better. I'm faster, I deliver a better software, more secure. I don't need to tell the others about my bugs because I can fix the bugs immediately. So essentially it empowers the developers. So it seems basically fantastic, no downsides. So let's imagine our typical CI/CD pipeline. I'm not being very rigorous here with the stages, but overall, so you have the pipeline where you commit, build, test, deploy, and so on and so forth. And then, okay, you think, I need security. Perfect, let's put security here. It's done, I have security in the pipeline. Yes, I can put security in all the stages, I know, but normally when you don't have any kind of security in the pipeline, well, you just place it in a single location. But let's put it here. What does it mean to put security on the pipeline? It can be multiple things. It can go from software composition analysis. I'll go a little bit deeper on all of these later. It can be about the dependencies. It can be that's about analyzing the source with SAST. It can be about actively testing the application with DAST, or some other kind of security, like for instance the traditional pen tests, where basically you appear here at the end of the process, and you are the guys that say no because you found a SQL injection or a header. For the purpose of this talk, and because, well, based on my experience, I'm much more familiar with Dust, I'm going to focus a little bit more on Dust first, and then we talk. Yes, I know. You got it right. But I'm going to focus a little bit first on Dust, and then talk a little bit about the others. So, okay, let's put Dust's dynamic application security testing on the pipeline. And Dust, for those who don't love the acronyms, is essentially testing the application, sending payloads, acting like an hacker. Okay, so I just enabled my Dust tool, whatever it is, on the pipeline. Okay, press start, then this happens, and this, and this, and this. And this is the experience of putting Dust on the pipeline. But it's all about waiting. Why? Because, well, based on some very methodical searches on the internet and also asking around people I know, most pipelines, and also inside our company, most pipelines take between 20 to 60 minutes. Of course, there are outliers, but it's in the order of minutes. Just for the sake of comparison, we do scans, we are Dust. 50% of our scans take less than 1 hour. It means that the other 50% take more than 1 hour. So we're already talking a higher order of magnitude. So going from 20 minutes to 80 minutes, maybe, or 100 minutes. And this also means that are a lot of scans that take a lot of hours. And this is not cool. This is not good. It's not good because it's a problem. And I've seen it in real life, developers waiting for pipelines, either because of security or just plain functional testing. And they don't like to wait. They don't like to wait. This slows down the whole process, makes them switch context, because if I know my pipeline is going to take an hour, I'm going to do something else. And if I do something else, I lose context. And then I need 5 more minutes or 10 to go back to my context. So this is not cool, because it takes a lot of time, and in the end of the month, all of that, those 1 hour pipelines add up, and it takes a toll. But it's not. So basically, you cannot delay the developers. The developers are not your enemy; they are your friends. And we, as the security people, we are not like. Unless our company sells a security product, we are not the product. We need to let the company build the product, and we need to help them. We need to create the conditions for the products and the developers to do their job safe in a more secure way. So we need to keep up with the developers. We cannot slow them down. Of course, sometimes we need to say no, right? But we need to work together with them to find the solutions and not put the roadblocks. So the obvious solution, okay, the scans take a lot of time. Why? Because the pipeline is slow normally, And this is very common, especially on development environments. So the development environments that we are using to test the application, right? We are pointing our scanner to our development environment, staging, pre-production, whatever you name it, are not only slow. Why? Because they are not production, so we want to save on resources. So if they are slow, the scan will take longer. If you are too aggressive with your scanning, you will take down your QA environment, and then you'll piss the developers, for sure. I'm pretty sure all of us did that. I did it multiple times. Never on purpose, but well, it happens. And also the CI/CD runners, so the machines where you run your pipelines are normally small. Again, because of the costs. And you don't want also pipelines running longer. Well, someone needs to pay for the pipelines, right? And not all of us have unlimited minutes of pipelines. We need to pay for that. So increasing the speed of the scan, like going to the tool and having more threads, or increasing the number of requests that we do per second, doesn't work normally. Either because you kill the development environment, or well, because you kill the development environment. That's essentially the main reason. So let's try different strategies. Basically, most people just say, okay, you need to put security on the pipeline, you need to find the vulnerabilities. They don't really talk about actual pragmatic strategies to do it. And the recommendation I like the most goes a little bit against more, I don't know, some security people that they feel they cannot miss any vulnerability, because if a vulnerability goes to production or if it's missed, it means they are doing a bad job. No, it's not about that. We are not here to find all the vulnerabilities, right? We are here to lower the risk or to raise the bar. We are basically, most of the times, we are just trying to push the hackers away to some other target, making it hard for us to hack. So, one strategy that works really well, it's to focus only on the high-risk vulnerabilities. Why? Instead of enabling my scanner, or actually any other tool, with all the vulnerabilities, like cross-site request forgery, or a missing HSDS header, I just enable SQL injections. Let's start with SQL injection. If I had to pick one vulnerability to enable, I would probably go with SQL injection. Because, a single one can take you down completely. And data can be exfiltrated and so on and so forth. So, if you disable the other 200 vulnerabilities and enable a single one, it's a huge speed up. That might not be enough. Another technique, and you can combine them, is to focus on the low-hanging fruit. What kind of low-hanging fruit? It can be only GET requests. It can be only unauthenticated requests. Why? Because, let's be honest, most of the attackers will probably only try this. Most of them will use a tool that it really sucks, so it's only going to be able to probably to get requests. It's probably doesn't have a good crawler, so the posts won't work, or it'll take a lot of time. They might not be able to create an account. So most of the attempts to find the vulnerabilities, and I'm pretty sure all of you got those emails saying, "Hi sir, please, I found a high-risk vulnerability." And they don't go in depth. They fire everywhere, and they go very shallow. So if you tackle those vulnerabilities, you raise the bar, and you probably move the hackers to somewhere else. Remember, I'm not putting here strategies to defend against cyber-sponsored state attackers. That's a whole different game. Or you can follow on common issues. If I know my company has an history of cross-site scripting issues because we don't use templates or because they are everywhere, I can also enable those ones. So let's reduce the scope and test less. With that, you get less vulnerabilities, so you get a manageable number of vulnerabilities. You get the ones that matter, you get faster pipelines, and you don't annoy the developers yet. You basically can do some trade-offs. Here, we basically reduce the coverage of the vulnerabilities by testing less types of vulnerabilities. But we can do the other way around. We can keep a higher number of vulnerabilities being tested, but test smaller areas. Which areas? For instance, the administration area, or the login area, or the area that changed. That's normally referred to as incremental scanning, where you only scan the changes since the last scan. So, in theory, this should be faster, right? Because, I don't know, maybe 99% of the site is already deployed and tested, and the changes only cover 5%. This is especially true if you are kind of agile and you deploy often. If you only do a deploy once a year, probably everything changes, right? So basically, you test a smaller area, and ideally still less vulnerabilities, because otherwise you end up with the same problem. So less vulnerabilities, less area of code to test. But these incremental scans, the idea behind it is really cool, but most of the times it sucks. It sucks why? Because incremental scans can be really blindsided. So suppose you have a function, an input filtering function on register.php file, and basically you change that function, and the tool will pick up that only that file was changed. And if the tool is not very smart, it will only test the endpoint register.php. And there's no vulnerability there. Why? Because the changes that you did there, the impact is only seen here. Because the input filtering function affects profile PHP, which was not changed, so it was not tested. And this can happen with scanners, like dynamic application security scanners. It can also happen with SAST, but less, because normally SAST has access to the source code and has a little bit more of context and can check dependencies. Or another example is if you do a SQL query by hand on booking utils .py, if basically those functions there are used only on /booking, and you don't test /booking, you're basically not testing anything. You are testing a function that is never called, so it doesn't work. You miss the vulnerability. And these examples, I like them because I specifically choose functions or that have a security purpose, so the impact is higher. So the way to handle this is to complement it with SAST. So we've been talking about testing less vulnerabilities, testing less area of the site. It feels we are not going anywhere because we are testing not a lot of things, but there's ways to go around this. And a way I like a lot is to basically do different levels of testing depending on the environment. It's unrealistic to expect to do a full or a big test on every commit or on every merge request, because if you have a big team or if the team is fast and if they do small changes and they put all the changes in separate pull requests for an easier review, you get a lot of pull requests. But you can do something like this. You do really light, shallow scans on every commit or in every pull request, so you don't delay the developers. And then you can do more longer scans, for instance, nightly, or just when the code goes to change environment. So while the developers are doing pushes to dev, you do basic testing. I don't know, you just test the headers. Something just to make sure they don't do a regression. But once you run the pipeline that deploys to the next environment, maybe you do a bigger test. Maybe now you add SQL injection testing. And before going to production, maybe you add cross-site scripting testing because you don't want the guys asking you for bounties because they found the cross-site scripting. And then you can do longer scans nightly. But even during the night might not be enough for a scanner to run. All of you that run scanners, and I speak against myself, right? I'm building one. Sometimes the scanners take more than 1 day to run. So one night is not enough. So maybe the only way for you to run a full scan with all the boxes checked, it's on the weekends. And that's fine. That's fine because you're basically already reducing your window of exposure. If you didn't have any scan, your window of exposure was infinite. With this, it's a week. So basically you reduce it a lot. So it's already an improvement you're basically doing risk management. I'm taking the chances of having the vulnerability in production for a week, or some types of vulnerabilities in production for a week. Go ahead.
I have a question. So, are you suggesting we should perform full scans in production on the weekend, including intrusive testing that can potentially break our application, for example?
This question?
No, it was because it was just because the last.
No, yeah. So this ends here and continues here. So answering your question, this was not on purpose. The sequence was cool. Should I scan in production? Who here is against scanning in production?
Depends on the application.
So you ask the hackers politely, do scanning.
So I would say it depends on the tests. So if you are performing intrusive testing, you should not do in production. But if it's passive checks, or mostly passive checks, it should be okay.
Oh, well, first of all, of course, the answer is depends, because there's different situations. Is the production application exposed to the internet or not? Are the users able to create an account by themselves, or I need to invite users, so there's some kind of vetting? My take here is that yes, you should scan in production. For multiple reasons. One is yes, the hackers will not politely stop scanning because it's a production environment. If it's exposed in the internet, it says prod. Let's not do it. It's Friday night. The guys are probably out of the office. Okay, let's not do it. That doesn't happen, right? So, there's also other reasons. The server configurations might differ, and normally production is a little bit better than the other environments. That's not always the case. There might be different network paths, and again, normally production is a little bit better, but you never know until you test it, right? Maybe staging as a firewall or a reverse proxy or something else, and production doesn't. Why? Because someone disabled it. Why? Because the CEO couldn't access something and called someone and they disabled the WAF. Why the CEO? Because I saw this happen once. Not with the CEO, but with the previous CEO. Where the guy just screamed at the phone, disable the firewall, because I cannot do something, and it went off for months. The libraries might be different. Not everyone do the proper way, like building an image and deploying the same image for all the environments. Sometimes people build an image for different environments, and well, what runs in production is not the same that in development. And there's a thing that I like a lot, and it actually, I have a special feeling for this one because it hurts me a lot when we sometimes at Pro we do deployments to production and something only breaks in production. I'm being transparent, quite honest. This happens to all of us, so I'm not saying that we don't suffer these problems, but sometimes we do deploy and something only breaks in production. Why? Because that specific account with that specific customization is only in production, and no one ever duplicated that condition to the test environment. So this happens, and it happens a lot in a lot of contexts. So only in production you have the real data, the volume. Another example I like is pagination. So if you forget to add enough data on your test environment, you never get to paginate the results. So maybe you don't get to see the other pages or the next or the whatever parameter. So with not enough data, maybe your test coverage is not good. But yes, you need to be careful. Of course, you need to be careful. And not in this life, but in the previous life, I took down more than one production site. I actually even did it while on holidays by accident. There's a nice story. I think it was you that called me. I took down the database and I didn't do anything. I just had a coma on an unsubscribe email, on an unsubscribe URL that was bothering me. And that's, or equal one, something like that. And basically that was an update or a delete, and I basically updated all the rows. So yes, you need to make sure you have backups and they actually work. If you don't have backups, you have a bigger problem, because you are basically just waiting for someone to ruin your database. We strongly recommend against using a real or an admin account, because the admin account will, well, the tool, if the tool is good, the crawler will find the link to delete everything. And also if the tool is not smart to prevent the clicking on the delete. So it's ideally you scan the test environments first, so that you break your test environments completely, and then it doesn't happen in production. So yes, I normally recommend scanning in production. You need to be a little bit careful. But if you're not scanning in production, someone else will, for sure. So just if you don't think so, just check the logs, and there will be scanners there. And the tool you are using is not quite inaccessible to someone else. If you are using Probably or Zap or whatever, someone else can buy the same tool and do the same. So unless your production environment is protected, I strongly recommend scanning production. Hope I answered.
There's a use case to his point. Is like if you don't want to scan production side if it's like an admin console where you can delete users and so on. So it depends on the site as well. Like
my comment was just regarding full scans of production during weekends. It was just
the moment really depends on your business. Depends on your business, right? You can do it in the weekends if you don't mind, if you are confident the application won't go down on the weekend, or your team doesn't mind working on the weekend if something goes down. We have actually a lot of customers that only scan off hours, because the applications, even with all the fine tuning and so on and so forth, they don't want to take any chances of performance impact on the application. And then I start to think a single tool can cause impact in your platform. Maybe you have more problems, right?
if it's only used by 10 users.
If it's only used by 10 users, yes. But again, if it's exposed to the internet, anyone can go there. So it really depends on your scenario. Where am I? Okay, good on time. Well, this is really nice. We've been talking about, let's put security in the pipeline. Let's make the sales team's dreams come true. That yes, we have a lot of people using the pipelines like we imagine. But that's hard for all the reasons I mentioned before. And there's also other ways to do it. And we've seen it. We have customers doing it, and it's smart. One of them is a synchronous scan. So the pipeline actually starts the scan, but the pipeline doesn't block. So the pipeline continues. What's the idea here? Is that you, security person or security team, that you want to make sure all the changes are tested, you are getting that, you are fulfilling that objective, because when the pipeline is running is because changes were done and the scan started. And basically it doesn't block the scan. So yes, you might be letting vulnerabilities reach a further stage or not. Maybe if you do this on the development environment, and you know your process from development to production takes a week, and your scan takes a day, you are still way in time to fix the vulnerability. So this is a really nice way for you to start the scans when it matters. Doesn't block in the pipeline. The scan doesn't even need to run in the pipeline, so you don't need to spend the team's CI minutes on the pipeline. It doesn't need to run there. It can run on a different tool. Just start it through its API. The pipeline continues, and everyone is happy. You get the scan. Eventually, you or the developers get a nice email saying you have a vulnerability, and they will fix it. So this is actually something we see a lot. Maybe it's the most common scenario, that people starting scans and not blocking the pipeline. So this is actually good, because if you think about it, you still have a huge chance of identifying the vulnerabilities before they get to production. So this is actually a very good technique. So it's not like we are basically, okay, yes, I'm letting vulnerabilities go to production. I don't care about anything. No, it's not like that. But if you don't really want to take chances, you can set up the tool. if it's possible, on the pipeline to fail on high-risk vulnerabilities. So yes, I'm saying I don't care about weak cipher suites, I don't care about TLS headers, I don't care about, I don't know, a missing CSP, I do care about the SQL injection. Or I do care about a specific type of vulnerability, XML injection, and I don't care about the others. So basically, it only fails on the high risk. This is good because hopefully it won't fail often, so you don't piss the developers too often, and you cover your back because you shorten the time to identify the vulnerabilities and you prevent them to go to production. So you can do these incremental changes, then you lower the bar to medium. And then eventually, if you are crazy, you lower the bar to low. But let's be honest, who fixes lows? So most people don't fix. They don't care about it. So maybe we should question ourselves, should we report lows? Yes, because compliance makes us, right? We get the reports from the guys that do scorings, and if we don't fix the lows, they scream. But we should keep the report of these vulnerabilities, and eventually they should go to the backlog. So all of this has a nice impact, a nice consequence, which is to reduce the alert fatigue. We know all these security tools have a lot of false positives, a lot of noise. We hate it, developers hate them. It's awesome if you want to show the board are doing a good job because you are basically as many vulnerabilities as you can find. In theory, you are doing a good job, but it doesn't work like that, right? So it's important to reduce this fatigue. Don't configure the tools to report everything for the developers because they'll get tired. They won't fix the vulnerabilities. They will find ways to go around the tool. They will still like you because you are the cool guys that help them and test the product. But they will find ways to ignore the tool or to go around or deploy without using the pipeline, bypassing the tools. So you need to be really careful with this. So small set of tests, I've said it. For instance, cross-site request forgery, they are really false positive prone. So disable them, we don't care. Yes, I know they can be really high risk, but we need to pick our battles. We should also maybe start testing on a more mature environment, not the first development environment, because well, it's underpowered. It has debug enabled, so you'll be basically screening vulnerabilities everywhere because you see the debug messages, and it's supposed to. So maybe we shouldn't be testing the development. Maybe we should test staging or pre-production, and also because well, these environments, the further left the environment is, the probably slower it is, and you know all the tools. If they see a slow response, they immediately say it's a SQL injection, right? Except Pro. I cannot say that. But if you used Burp before, I used it too many years, so if it's slow, it will scream that's a vulnerability. So Dust is just a part of the ecosystem. And unfortunately, we cannot get away with just a single tool, right? Even if we buy all of this, you probably still need to do this. Why? Because, well, none of these can replace the human creativity and mind, and most compliances still require a pen test. So we don't have a workaround. But maybe we can add all of this and basically have a smaller gap. Instead of 1 year gap, we have a 1 day, 1 week gap. So, talking a little bit about the others, the software component analysis, where we basically try to identify the dependencies of our tools, of our product, and the ones that have vulnerabilities. They are normally really fast, but they are really overwhelming. And I think the word overwhelming is the good choice, because basically you enable sneak, samgrep, whatever. You enable, you get immediately, well, especially if you use nodes, right? You get immediately 2,000 vulnerabilities. Oh my God. What am I going to do with that? Nothing, because like only 10 of them have a fix. So you are left with 1,900 vulnerabilities that you don't know what to do, and now you have to hide them from compliance, right? Because you don't know how to fix them. So you just increase your problem. But SCA has value. My recommendation here, and I went through that process, is to enable it on a very particular subset of the application, or just an application, or just a domain, something really small, and just care about the high risks, vulnerabilities. Because, and even like that, if it's a node, again, you won't get rid of all the findings. But well, you need to start somewhere. Something that is really cool are tools that do this, that automatically create a pull request. That saves a lot of time. It's cool when the pull request only increments the minor. It's not that funny when it requires a major upgrade, and basically you are not getting anywhere. But at least you get visibility. You can buy your boards to give you more time. SAST, or static analysis, that looks at the source code, and normally they complement that DAST pretty well. SAST is also normally faster than DAST, and actually, from what I saw, most people start with SAST, with static analysis, pipelines. The problem is that it's way worse than all the others in terms of false positives. It's so annoying, it's so many false positives that it becomes unusable. So again, you need to be very selectively on what to enable. Really picky, only care about the high-risk stuff, don't care about minor stuff. For that, the developers have their IDE. But these are really, really false positive problems. Why? Because they don't have the context of the application running, so you probably went through that. IaaS, or interactive application security testing. It's interesting because since it attaches to the application and can see the inputs going down the code and hitting the database, if they see a payload hitting the database or the connector to the database, it generates a real finding. It's hard to generate false positives. The problem is that these tools can only work if they see traffic. So you basically need to somehow generate traffic. You need to force and test your application so the inputs go down the code paths and the agent can see the inputs reaching the vulnerable code. But it works. It's kind of interesting. But it requires an agent, which is sometimes something we don't want, right? We don't want like the security team convincing someone else to install an agent on their code base. It's not way faster. And the security team also doesn't have the liability of putting their code on the application that generates the revenue for the company. Another take, go ahead.
I just want to make a comment on Rust. Like some people also like to run it on production. But imagine if you have 10 servers with a load balancer, you can put it in just 2, for example, and you will get a good result, for example, doing that.
Yeah. The problem with IaaS is also that, well, you're going to detect the vulnerabilities, but you might detect it only when it's being explored. So I don't have a lot of experience with IaaS, so I'm not sure how good or if they can stop the vulnerabilities from being explored or not. Probably not.
Depending on the architecture of the application, it might not be feasible as well. Imagine that you have an application that has a lot of different microservices in different technologies.
Yes.
You need an agent installed on like everywhere, basically.
Yeah, of course, it depends. Just
No, of course.
Something
It depends.
that
It depends a lot on a lot of factors.
That's also good because you probably said
Well, but each microservice should be secure, right?
right.
Each microservice should be secure in your example.
It just might be unfeasible for testing the sake of an application to install the agent on all different microservices. You might not even have the agent for that particular programming language that one microservice is built on.
Who here runs an IaaS?
I have experience with that.
But you run it today? You gave up? No.
No, it's in a different capacity.
Okay.
But what you're describing today is a lot of challenges related to Dust that don't exist. Yeah, that don't exist in IaaS.
Yeah, exactly.
And the context also that you give a developer is way higher.
No, it is. It's like SAST. You can pinpoint the line that has the vulnerability. With Dust,
data flow.
Yeah, with Dust you probably say you have a vulnerability on /booking.
Yeah.
And the vulnerability is 10 miles away, I don't know, in a different application, in the back end somewhere different.
So we are using a tool that is not the YASP, but the Prisma Cloud does that. It's focused on what's happening on your runtime and gives you information about, so this vulnerability that is a medium, but it's really important because it's exposed, it's out there.
And he probably can tell you, I'm seeing payloads, or something is hitting it. So the good thing, as I mentioned, false positives are unlikely. So whenever it screams, you should listen. Another take that's, well, this is more a take a position that I'm adopting, and as I shift more to someone that manages priorities more than vulnerabilities, is that your vulnerabilities should be treated like any other bug. What I want to mean with that is that don't be the security guy that, oh, this needs to be fixed because it's a security vulnerability. Otherwise, you probably might end up with those nice wars that we are seeing now in the Linux, in the kernel, with the guys fighting all the CVs that are being reported. So basically, my take here is that your vulnerabilities are like any other bug. They need to be discussed, prioritized, and planned. Because some of them, yes, if it's a SQL injection, you probably need to, well, maybe not wake up someone, but you probably need to fix it first thing in the morning. But if it's a missing header or a cross-site request forgery, come on, let's be realistic. We need to discuss it. We need to talk with the team to think about the impact of doing that change. It's probably not that high priority, right? Because you have something else in place that mitigates it. So all the vulnerabilities, in my opinion, should be treated like all the other bugs, and they need to be discussed. They need to be registered. They need to be registered on the same issue tracker that the developers already use. Because let's face it, the developers are already using Jira. They don't want to go to another tool. They don't want to go to Probably or whatever tool they are using. They want to have their tasks on the same place they are getting. They want to get their vulnerabilities in the same place they are getting the other vulnerabilities. Let's not make the developers go to a different product because they'll probably forget about it and they won't go there. So, and that also has the advantage of bringing visibility to the security issues, not only to the developer, but to the product owner, product manager. So basically put everything on the same bag. Of course, security bugs might have a higher priority if it really makes sense, but it should not treat vulnerabilities as a special thing just because it has the label vulnerability. So other cool things that I've seen it, we've heard it, that can really improve your the way you test your applications, not necessarily in the pipeline, but basically they help you towards your objective of testing the application better, more often, as early as possible. One really cool is to scan the HAR files. So these are files the browser generates with a sequence of requests, which is really nice. Sometimes the QA team build these files, and if you feed your tool with them, basically you are instructing the tool test this sequence, and you are helping the tool because not all the tools can figure out the way to do the checkout and complete the payment and the booking and everything. So if you give them the sequence of steps, you ensure the tool goes and tests all those steps. Another really cool is to piggyback on the QA team. So why not ask the QA team to configure this innocent proxy on their browser, and maybe all of their tests go through your tool, through your corolla. What you are getting here is coverage, because you no longer rely on a tool to find all the endpoints of your application. You are relying on the QA team that already needs to go to all the endpoints and providing the right values. So if you do this, it's really cool because you feed your tool with real data. Postman collections are also cool. A lot of QA teams and developers have Postman collections. Even for them, they're functional testing. So to test, make sure the changes work. So if you can somehow ingest these Postman collections and test the sequence that is described there, you get really nice coverage. So conclusions, and this is something I haven't mentioned before. Scanning in CI/CD is really hard. There's a lot of challenges. So there's another solution or another recommendation that maybe it's should be your very first step. Instead of putting scan security in the pipeline, just schedule a scan. Right? Don't care about the pipeline. Schedule a weekly scan. It's already better than waiting for the developers to come up to you every 15 days asking to test something. Schedule a weekly scan. Schedule it on Friday, and you have the results on Monday, hopefully, or on the weekdays if you prefer. So that's already one step better than not doing scans or just scanning on demand. Then you can start waiting the CI/CD incremental. Only a subset of vulnerabilities, really. Disable everything and enable one by one. Because I tell you for sure, as soon as you enable a single one, you'll get a lot of noise. False positives, things blowing up, the developers complaining that you basically, not the developers, the marketing team complaining that they got 20,000 requests on their CRM because you filled the contact form. It's full of wait for delay and things like that. So even a single vulnerability will cause you a lot of pain. So go slow. Start also with the synchronous scanning. So don't block the pipeline. Just fire a scan on the pipeline. Don't care about the pipeline. And just trust that the scan will end and you'll be able to fix the vulnerabilities before the code reaches production. Or you just assume that they might reach production, but for a shorter period. But whatever you do, basically the most important thing, this is more a take on the security portion that we need to have as security people, that don't get in the way of the product. So don't fall in the temptation of just putting something on the pipeline because someone said it was cool. Do something, but be careful. Don't piss the developers, don't delay the teams, otherwise they'll go around you, right? If you go against the product, they will kill you. But, well, you need to scan, so please scan something. And that's it.